is Prashant Chaudhary and I'm your instructor for this course. I welcome you all to the course 101 programs to build your programming logic step by step. So let us start. So what is C? C is a high-level language founded in 1972 at AT&T's Bell Labs. It was founded by Mr. Dennis Ritchie. C became very popular because of its large feature list and speed. Most of the operating systems, embedded programs that are used for microprocessors and games are built using C language. Many softwares which are built using C languages. Even today, many consider C language to be their first language to learn coding because of its simplicity. So when we write a C program, that program is basically used by compiler. It compiles that code to convert it into machine language code. Machine language code is the code which computers can understand. They cannot understand C program code directly. However, writing C programs is easier for us. So that is why instead of writing directly code in machine level language, we can write into C programs, which is a high level language, which is closer to English as compared to machine level language code, which is usually ones and zeros. So it becomes easier for us to write C program and then use compiler, which is again a system program which takes this C program, compiles it into machine level language for us. We're going to check a code block for C program. Every C program has this hash include in the angular brackets header files. So what these header files are? All header files contain predefined functions which we can directly use. We can also call them as dependency files, which can be used by your actual C program. We can include one or more header files. All C programs start with a fixed function name called as main. This is our main function. Every function in C returns a value. In this case, I am returning a value as int. We are going to check this in detail in next lectures. So the starting curly braces and ending curly braces indicates the point from where my main function starts and where it ends. So all the lines which are between this parenthesis are my block of main function. Now let us check this in more detail. So these are my include header files. I can have multiple include statements. Then my main function starts from here. Now inside of my main code block, what I can have is declaration statements, decision control statements, loops, call to other functions, special keywords, and my return value. All these points we are going to check one by one in the next lectures. Before that, just want to make a point that how exactly a program is executed. Now, when we say execution, it doesn't mean actual execution, but when we talk about the compiler compiles your code line by line. And when it gets converted into machine code, that machine code is also executed line by line. So when I say a line, it's basically an instruction that we are providing to the computer. So computer executes your code block instruction by instruction. That is why it is necessary to understand how exactly we can instruct the computer in stepwise manner so that we can achieve our desired output. Now we are going to talk about format specifiers and basic functions that we require in order to take input from the user or to display our output to the user. So those commonly used functions are printf and scanf. Because we'll be requiring these functions quite often, so I'm covering this in the initial lecture only. So there are many format specifiers in C language. However, we are going to use %C, %D and %F for now, and rest of the format specifier will be checking in the next lecture. So %C will be used for character, %D will be used for integer, and %F will be float. So all these three data types we are going to check in the next lecture. Format for printf and scanf statement is like this. So let me explain how printf statement will be utilized. Printf, then starting double quote indicates starting of my string. So what I am writing over here is a number, %D, comma, a character, %C, comma, a float value, %F. And then I end my first parameter with another double quote. This whole part is my first parameter of the printf statement. Then I'm writing comma to add another parameter. So my next parameter is marks. Then again a comma, this is my next variable, and again after a comma another variable. So how exactly this printf statement will get executed? So at the time of compilation, my %D will be replaced by marks. this whole variable will be replaced by %c, and similarly my final variable value of pi will be used to replace %f. So hence, once this is compiled and at the time of execution, my output for this printf statement will be a number 10, comma, a character p, comma, a float value 3.142 if these variables were having these values. Now, next statement is scanf statement. So printf statement is used for displaying values. So this is used for displaying output, and scanf is used for taking values from user. So what scanf does is it tells compiler to take these three values, and I'm also mentioning what type of value to take from user and where to store those values. So when I say %d, I'm going to accept integer value, %c will be my character value, %f will be a float value, and all these three values will be stored one by one into these respective variables. My first integer variable will be stored at marks. My second parameter is character variable, which will be stored into this variable, first letter of your name, and %f, which is a float variable, will be stored inside of value of pi. Now we are going to write our first program in C. So these are include statements. I'm writing include stdio.h and conio.h. So these are two files which you will require for using clr and getch function. These are very common functions. So what clr does is basically clears your output screen. So whatever output that was there of the previous executions will get cleared out. So you will have a complete blank screen. So once your screen is clear, we are just displaying printf codegod.com. And once that is done, I'm just writing getch so that you have some time to check your final output of the program. So till the time you don't enter any character from your keyboard, the compiler will wait and the program will not get terminated. So once you enter any character from keyboard, the program will get terminated. So this is a very basic program to print a simple string on output device. Now we're going to check character sets and constants available in C language. So character set in C has all alphabets starting from capital A to Z, small a to small z, all digits from 0 to 9. We call them as decimal numbers, special symbols which are visible on your keyboard, and additional ASCII characters that will check in coming lectures. In C language, constants are of two types: primary constants and secondary constants. So what are primary constants? Those are basically three types. Primary constants in C are integer, real, and character. This we have seen in previous lecture. Integer are basically whole numbers. So these are few examples: 786, plus 501, 0, minus 09. These are few integer constants. Similarly, we have real constants which have decimal point into it. So 3.142 is a real constant. Minus 21.444, 55.00. These are also real constant. Then we have character constants. So small a, capital A, all special symbols. In fact, digit 9 as a character can be a character constant. Then we have secondary constants: arrays, pointer, structure, union, enum. These are secondary constants. We are going to check all these as our study progresses. Now we are going to check basic data types in C. So we are going to start with int, float, and char. In the earlier lecture, we have seen character sets which is available to us in C. So integer, real, and character are basic C constants. How we can utilize those in C is using data types. So int is your integer which can be utilized to store whole numbers, real values, or the values which contains decimal point. So these are few examples for data type. Float, these are few examples for character data type. So A, X are characters. Space is also a character. All digits can also be displayed as a character, and all the special symbols too. Apart from these three basic data types, there are more data types available in C, but that we will check in coming lectures. Now we are going to check what variables are. In C language, variables are used to store values which user has entered or we calculate few values and we store our results into those variables to display output to the user. So there are few guidelines or rules in C to declare your variables. First point is, ideally your variable name should indicate what value it stores. Like, suppose I want to store a roll number, I should ideally declare the variable like this, roll underscore number. Because just writing R or A, B, C doesn't make any sense. Tell the programmer what exactly this value the user is storing. However, while developing programming logic, we might be using these variables in the shortest form like X, A, B, just because of the simplicity. But ideally, you should be writing variables in a better way so that you can understand what value it stores. Second point is, ideally, we should assign some value at the time of declaration. Otherwise, it will hold some random value and it can create some logical errors. Logical error is basically something that your program does not contain any syntactical error. It will execute, but it won't give you the desired output. So logical error makes your life very difficult because you have to debug and what exactly the computer is doing because it is giving you a wrong output. Variables should not contain any special character, but it can contain an underscore. Variables must start with an alphabet or underscore, and variable must not be an keyword. As we have seen in the earlier lecture, int, float, char are used as data types in C. So obviously you cannot have a variable name as int, float or char. So these are all special keywords which cannot be used as a variable name. So these are valid variable names, like I'm saying, roll number, pi value, O, underscore super cool. These are valid variables, but these are few invalid variables. So roll dash number, why this is invalid? Because it has a dash and we cannot use special symbols apart from underscore. We cannot use constant as a variable name, and also a variable name must start either with alphabet or underscore. Here it is starting with a constant, character 0. Why? Again, because it's a number, it's a integer constant. It is not an alphabet, that is why we cannot use 0 as a variable name. Also, we cannot use keywords, like if is a special keyword in C used for decision control structure, which we are going to use in coming lectures. That is why in specif is also invalid. Now we'll check how we can declare a variable in C. To declare a variable, we must write data type first. In this case, so far we have seen int, float and char are data types, so we can use based on our choice which data type you want to use, and then your variable name. You can also initialize a variable, which is a good practice of programming, using equal to operator. So here are a few examples. I am writing my statement as int space x semicolon. Semicolon is a character which is used in C to tell compiler that my instruction ends over here. So when I say int x statement completes over here, I can alternately write multiple instruction on the same line like this. Okay, but to have good readability, we write one instruction below the other. So when we declare a variable, what happens, assuming this to be your computer memory, when we declare a variable int x, compiler allocates memory to this variable. It names it as x, and this is address location of my x variable. When we do not initialize a variable, it will hold some random value. However, in case of y, what has happened? We are initializing y to 10. So when compiler allocates memory to this variable y, it is also overwriting value with my initializer, which is 10. So in case of x, this random value which was already there, we refer to it as a garbage value. Now we are going to check operators in C. C language has wide variety of operators. So these are all different types of operators which are available in C. However, for our current scope, we are just going to check assignment operators, which is equal to, plus equal to, minus equal to. There are few more assignment operators, but we'll check those in next lectures. So when I write instruction as a equal to 10, so a will hold value 10. In this instruction, value of x will be overwritten by value of y. The next example is I'm writing x is equal to x plus y. So suppose my y is, let's say, 2 and x is, let's say, 10. So my x will become 12. So this addition will get stored into x. So there's an alternate way in C. Instead of writing x is equal to x plus y, we can use plus equal to operator. So it works in the same way. What it says is increment value of x by y. So I'm saying increment value of x, which is 10, by 2. So my x becomes 12. Similarly, instead of writing a equal to a minus y, I can write a minus equal to y. In other words, I am decrementing value of a, which is 10, with value of y. So 10 minus 2, 8 will become my new value of a. Apart from assignment operators, we also have arithmetic operators. So plus, minus, instead of multiplication like x, we use star operator in C as a multiplication operator. Then division, and then modular division as well. So there's a difference between division and this percent sign. So in case of normal division, suppose I am going to divide 7 with 2. Okay. So in this case, this will be result of my division, and this will be division of my percent sign. So when I write instruction like 7 divided by 2, my output will be 3. And if I write 7 modular division 2, my output will be 1. Similarly, if I write 3 modular division 3, it will be 0. And 3 divided by 3 will be equal to 1. I'm taking another example. Let's say 17 divided by 15. So output of this will be 1. And 17 modular division 15. In this case, my output will be 2. Now we are going to check our arithmetic operators. So these arithmetic operators can be used like this. For simple multiplication, we can write a star b. For addition, a plus b, a minus b. For subtraction, a divided by b, and a modular b. This all we have seen in earlier lecture. Arithmetic instructions utilize arithmetic operators to write our calculation statements. We can simply write something like this, or we can use brackets. Ideally, I'll suggest you to write brackets wherever possible to avoid logical errors. Similarly, this is multiplication sign over here. This is division sign. Now, there's precedence also we need to take care of. Okay, so if you remember normal Bodmer's rules, precedence will be given to percent, multiplication, division, then plus and minus, and then to equal to symbol. So assignment happens when all the calculations are done. If you have enjoyed this lesson, give this video a thumbs up and share it with your friends. Subscribe to our channel for more videos like this. Also, don't forget to visit our website codegod.com for more detailed content.